I'll talk here about something that's called order statistic, and I'll explain it with a city bus because I live in Brooklyn, so I know I'm close to a lot of city buses. There are some places where or 5 or 6 city buses stop in some major, like Kings Highway and East 16. All kinds of buses stop there. Some of them go to Manhattan, to Brooklyn, all kinds of directions. Let's say 5 different buses stop there. The B16, the B68, whatever. 5 different buses. Now, another assumption, it's not true, but it's good for assumption. Let's assume that each city bus can come once in 20 minutes. That's how the rule is. You come there, you complete 1 minute, 2 minutes, 3 minutes, up to 20 minutes. Every 20 minutes is another city bus. And this applies to every single bus, every single route, that they have this rule that they come once in 20 minutes. Now, I go there and I'm standing there by this big bus station where all the 5 different buses stop. And I would like to write down on a paper how long I waited for each bus to arrive. So first this bus comes and that bus comes, and it can be different orders, one bus, another bus. But I would like to know another question now. I said 20 minutes. Within 20 minutes every single bus will arrive, because it's impossible for a bus to take more than 20 minutes. So my question is now, I write down this bus, 1 minute, other bus came after 5 minutes, other bus came after 10 minutes, so on. So the first question is, we can ask, what is the probability that we should have all 5 buses arriving in less than 10 minutes? That's a very nice question, and it's quite simple to answer. Since each bus has an independent, each bus doesn't know from the other bus, and each bus can arrive in an interval from 0 minutes to 20 minutes. So there's a 50% chance that in a certain individual bus will arrive less than 10 minutes. If I wish all 5 buses to arrive, so it's 50% times 50% times 50% to the 5th power, that's a half to the 5th power, that's 1/32, quite a small chance that all 5 buses shall arrive in less than 10 minutes. Okay, then I can ask a second question. How about, I would like something else. I would like at least 4 buses shall arrive in less than 10 minutes. That's a nice question to ask. I don't care which buses. I'm just interested to have at least 4 buses arriving in less than 10 minutes. If all 5 arrive in less than 10 minutes, I'll be even happier. If I see at least 4 arrive in less than 10 minutes, then I don't know why I'll be happy, but let's assume that it shows that I feel it's a lucky day. So many buses coming. So have at least 4 buses arriving in 10 minutes. That will do the job. So here let's look a little bit, not too difficult. Let's break it down. It's, if we have all 5 buses arriving, that's obviously we met the condition. That's the best possible. So that's 1/32. To have 4 buses arriving and then the 5th one arriving after 10 minutes, will also be happy. What is that probability of having 4 buses arriving in less than 10 minutes and the 5th one arriving after 10 minutes? The answer is very simple. Again, a half to the 5th power, because the first 4 have to arrive in the first half, and the second and the 5th bus should arrive in the second after 10 minutes. However, this can happen. Which bus should be the unlucky bus, the one that arrives after 10 minutes? It can be 5 different buses. So to sum it up, we have here 5 times a half to the 5th power. Again, I'll explain it again why. Let's assume we have, I'll give names for the buses. We have a bus A, B, C, D, E. You have these big letters on each bus, A, B, C, D, E. So it's either bus A, B, C, D arrive the first 10 minutes and E arrives after 10 minutes. And if this should happen, it's a half to the 5th power. A half to the 4th power is the A, B, C, D should arrive before 10 minutes times a half, due to the fact we want that the 5th, that bus D should arrive after 10 minutes. That's also 50% chance. However, who says we need A, B, C, D to arrive in the first 10 minutes and E to arrive after 10 minutes? We can have A arrive after 10 minutes, or B arrive, or C, or D, and the rest arrive before 10 minutes. So again, the unlucky bus can be either A, B, C, D, E. So there's 5 times 1 over 2 to the 5th power. That is again, that is the probability that we should have at least 4 buses arrive. At least 4 buses arrive the first 10 minutes. But we need to add the situation. Maybe we'll be really lucky. We'll have all 5 buses arrive in the first 10 minutes. That's another small probability. It's 1 over 2 to the 5th power. So to add together all of this, I'll write it down on the paper. You should see clear what we're doing here. Okay, bring it close to the camera. You see here, 1 over 2 to the 5th power plus 5 times 1 over 2 to the 4th times a half. 1 over 2 to the 4th means the 4 buses arriving in the first 10 minutes. A half means the unlucky bus arriving in the second, means from 10 to 20. That's also 50% chance he should arrive late. And 5 is due because there's 5 different ways, times 5 different ways how this can happen. It's either the bus A that arrives late, or bus B, or C, or D, or E. So there's 5 ways how to have this thing happen. And then we have 1 over 2 to the 5th. That's the case where all 5 buses arrive in the first 10 minutes. So you use a calculator. You do 1 divided by 2 to the 5th plus 5 times 1 by 5 times Okay, with the calculator I got 0.1875. That's 18%, not too bad. 18% chance that we should have at least 4 buses arrive. We'll do one more example, then the rest everybody can do themselves. How about having, I'll be happy even with 3 buses. I want any 3 buses to arrive in the first 10 minutes. That will make me very happy if I get at least 3 buses arriving. So here we have already, we have to add this case where all the 5 buses arrive, where only exactly 4 buses arrive and the 5th one arrives later. Now we'll add another case where exactly 3 buses arrive in the first 10 minutes and the other 2 arrive later. So to make, let's illustrate it. Let's assume we want A, B and C to arrive the first 10 minutes and D, E arrive after 10 minutes. Again, it's an easy example because I made it exactly by 10 minutes. It's exactly the half, so it will always be a half to the 5th power, because the 3 buses arrive in the first 10 minutes and the other 2 arrive the second 10 minutes. That's from 10 to 20. So anyway, it's again 1 over 2 to the 5th power. Here, this is something different. The 2 unlucky buses, the ones that will arrive after 10 minutes, can be either AD, AC, AD, AE. We said the example that DE, but it can be any 2. So we know that we can choose any 2 buses out of 5 in 10 different ways. That's because 5 choose 2 is 10, that you should know from combinations. So it's just simply 10 times 1 over 2 to the 5th power. I'll write it down on the paper and I'll show it to you. 10 times 1 over 2 to the 5th power. So we're simply adding this 1 over 2 to the 5th power. That's all 5 buses arriving, plus 5 times 1 over 2 to the 4th times a half. That's 1 over 2 to the 5th, plus 10 times 1 over 2 to the 5th. That is, we're taking this 1875 and we're adding 10 divided by 2 to the 5th power is 3.3125 plus 0.1875 is exactly 0.5. So this is an interesting fact, that there is a 50% chance. It's not so obvious, it's not so self-intuitive, but that's the fact. There's a 50% chance to have at least 3 buses arriving the first 10 minutes. At least 3 buses. Oh, actually it is self-intuitive because it's symmetrical, this case, so it's quite obvious. It's not so. This is an easy example. Okay, so we understand to have 3 buses arrive, that is 50% chance. Okay, I hope you enjoyed this. Thank you very much.